All right, today we're going to tackle a classic programming puzzle, the container with most water. Now, it looks kind of tricky at first, but the solution is so simple and elegant, it's just a beautiful example of some really clever problem solving. So let's dive in.
So, here's the mission. You get a bunch of vertical lines, all with different heights. Your job? Find two of these lines that, when you put them together, create a container that can hold the absolute most water.
Just imagine these bars are numbers in an array. You can see, right? Picking different pairs of lines makes different containers. Our one and only goal is to find the pair that gives us the biggest possible blue area, the one that holds the most water.
Now, you could, of course, try the brute force way, pair the first line with every other line, then the second line with every other line, and, well, you get the picture. With thousands of lines, we'd be here all day. There has to be a smarter, faster way to do this. And trust me, there is.
Okay, but before we jump into the slick solution, we gotta lay down the ground rules. How do we even figure out the area of one of these containers? It's really simple, but it is absolutely crucial to understand.
The area is just the width between the two lines multiplied by the height. And here's the kicker. The water can only fill up to the height of the shorter of the two lines. That shorter line is our bottleneck. Think of it like this. The water's just going to spill over the shorter side, right? It doesn't matter if the other one's a skyscraper.
All right, now that we've got the rules down, let's pull out the tool that's going to crack this whole thing wide open. The two-pointer strategy. It's a fantastic technique for zipping through array problems like this.
So here's what we do. We pop one pointer, we'll call it L, at the very start of the array, and a second pointer, R, at the very end. This gives us our very first container to check, and it's the widest one possible. We'll calculate its area and just keep that number in our back pocket as the record to beat.
Okay, so now we have to figure out how to move these pointers inward to hunt for an even better container. And honestly, this next bit, this is the whole magic trick. It's that aha moment that makes this algorithm just sing.
So here's the million-dollar question. Once you've calculated an area for your current L and R pointers, which one do you move? Do you move the one on the taller line or the one on the shorter line? Just take a second and think about what makes the most sense. And bam, this right here spells it all out. Let's say you move the pointer from the taller line. Well, your width gets smaller, but your height is still being limited by that same short line. You're guaranteed to get a smaller area. It's a dead end. But if you move the pointer from the shorter line, yeah, the width still shrinks, but now you have a chance, a real shot at finding a new, much taller line that could totally make up for that loss in width. It is our only hope for finding a larger area.
Okay, enough theory. Let's put this into practice and see how it works in the real world. We're going to walk through our example step by step and solve this thing together. All right, let's get started. Our left pointer L is on that first line, which has a height of 1. Our right pointer R is way over on the last line, height 7. The width between them is 8. Now, since that left line is our bottleneck at height 1, our first area is just 8 times 1, which gives us 8. So that's our current record to beat.
Okay, decision time. What's the move? The left line's height is 1, the right is 7. The left one's obviously shorter, so based on our big aha moment, we know we have to get rid of that shorter line. We move the left pointer one step to the right.
And boom! Look at this! Our left pointer is now on a line with height 8, and our right is still on 7. The new width is 7. The shorter line, our new bottleneck, is now the one with height 7. So what's the area? 7 times 7, that's 49! Wow, that just completely smashes our old record of 8. So we update our max area. And now, the right line is the shorter one, so our logic says, move the right pointer in.
And that's really all there is to it. We just repeat that simple dance. Calculate the area, check if it's a new record, and then slide the shorter pointer inward. We just keep doing that until our pointers finally high-five in the middle.
So after we run this whole process to the end, what's the biggest area we found? Yep, it was 49. And that's our answer. See how elegant that is? Way better than checking every single possible pair, right?
And you know what's so cool about this? All of that powerful logic. It boils down to some really simple, clean code. Let's take a look. So the code kicks off exactly how we did it by hand. We set up two variables, L for left, starting at index 0, and R for right, starting at the very end of the line. We start with the maximum possible width. And the whole thing runs inside this one while loop. It just says, hey, keep going as long as the left pointer hasn't caught up to the right pointer. As soon as they meet, we know we're done. We've checked everything we need to.
And this right here, this is the engine of the whole thing.
It's our aha moment written in code. It's just a simple check. Is the line on the left shorter than the line on the right? If it is, we bump L up by 1. If it's not, that means the right one is shorter, so we move R down by 1. That's it. That one simple decision repeated over and over is what makes this so brilliant. So, let's wrap this up. What are the big takeaways? First, this thing is fast. We're talking O of n time, because our pointers only make one pass through the data. Second, it's super efficient with memory, O of 1 space. We don't need any extra lists or anything. And the absolute key, the one thing you have to remember, is you always move the pointer of the shorter limiting line.
And there you have it, the container with most water problem, totally cracked. This two-pointer technique is just such a powerful pattern to have in your toolbox. So the question I'll leave you with is, now that you've seen it in action here, what other tough problems out there could you solve just by having two pointers dance their way to the answer?